So now that we know what our consumption function looks like, let's graph it. Since I am not doing your classic supply and demand, this is actually a different graph about consumption and production than you have seen in the past. So instead of thinking of this as the demand function, think of this as the consumption function, which will help you remember something. That unlike all of those supply-demand graphs that you encountered, this one was a graph developed subsequent to Keynes. It's not following the original Marshallian formulation. And that means that while that graph had the axes flipped for historical reasons, this one's going to have the usual axes that you're used to, where the x-axis is going to be the independent variable and the y-axis is going to be the dependent variable, all right? So that's the first thing to remember. In this case, the x-axis, which is the independent variable, is y, because consumption depends on your income level, all right, or your real GDP level. And just to remind you, y is the same thing as real GDP. Over here, I'm going to call that C. Here is a second feature of this graph. The units on both the x-axis and the y-axis are the same, because everything is being measured in constant dollars, all right? Because that's how I'm doing the measurement. I'm measuring everything in constant dollars. So what that means is everything has exactly the same unit. And so this is a very interesting element which is going to make this graph usable in some interesting ways. So as long as you remember to ensure that you've got the units aligned correctly, you'll be able to do a lot of fun things with this graph. So just remember, whatever units you're using on the y-axis, you want to make sure you're using exactly the same units on the x-axis and vice versa, all right? What you're using on the x-axis is on the y-axis. With that in mind, let's go ahead and plot our consumption function. When you have no income, you will still consume something. Then, as your income goes up, your consumption will go up. This will be a positive line. And because my MPC is a number between 0 and 1, so it's a positive slope, this slope will be less than 1. Everybody got that? So this line is very particular. It's a straight line, it goes up, it's positive, and when you draw it, remember the slope of this has to be less than 1. Starts at a point above the 0 and it goes up like that. Second thing, I am now going to add a visual technique that we use a lot in Keynesian economics, which I will call the 45-degree line. Again, this only works in this graph, in our aggregate income expenditure graphs, because the units are the same on both axes, right? So over here, I'm going to make it dashed. That's 45 degrees. Now here's the interesting thing about a 45-degree line, right? All of you have done geometry, you've heard about triangles, and you know that if I've got a 45-degree line here, if this is a 45-degree line, and I drop this straight down, That means that's a 90-degree angle, right? I know that by definition, this distance is going to be the same as that distance. Can everyone see that? Because the units are the same, here's what happens. This distance that I'm going to call OY1 is going to be the same as this distance that I'm going to call Y1B. Right? Here we go. So using the 45-degree line, I can find something very fascinating. First, the 45-degree line has a slope of 1. It starts at the origin and it's got a slope of 1. The consumption function will start above the origin and it will be flatter than the 45-degree line because it's got a slope of less than 1. All right? So this is going to be upward sloping, starting above the origin, and it's going to be flatter than the 45-degree line, which will start at the origin and go like that. All right? I can use the 45-degree line to say that supposing this 0y1 is my income level. Let's say this is an income level of 7,000 billion of US dollars. So let's say this is 7,000 billion. That means by definition this distance is also 7,000 billion. All right? How much am I consuming at that income level of 7,000 billion? I figure that out from my consumption function. Over here. This distance is my consumption. Right? If all the way up to B is my income, and this amount up to C is my consumption, then it follows that this difference is savings. Because by definition, savings is what's left of my income after I've consumed. So, income, consumption, savings. I was able to read all three of them off this graph, and in this case you can see that since my income is higher than my consumption, that's the amount of savings. Over here at very low levels of income, where my income is below my consumption, this indicates an area of negative savings, where I'm actually consuming more than I make. We're going to talk about when and how countries end up in such a situation. This can actually happen every so often. It's not usual. Most countries don't actually operate there, but there's sort of very interesting moments when you have very severe savings or very high levels of borrowing and things like that can make this happen. But overall, negative savings, positive savings, right here, this place where the 45-degree line crosses the consumption function, my income is exactly equal to my consumption and I have zero savings. So here we go. Your first major element in your Keynesian model. Keynes' theory of household consumption. He argued that most households essentially make a decision to consume ceteris paribus based on their income level. It's the sort of biggest or most important determinant of your total consumption, right? And that if you think about consumption behavior, the average consumption function for an economy looks like this. Certain level of consumption that will happen regardless, and then the marginal propensity to consume, which is going to be the single most important thing that we're going to use in this Keynesian model, will be a fraction between 0 and 1. By definition, marginal propensity to save will be the rest of that fraction, so that will be 1 minus MPC, and we can depict it in this kind of picture picture where I've got Y, or real GDP, on the x-axis. I've got consumption on the y-axis. I am back to having my dependent variable up here and my independent variable down there. And I can capture Y, which is income, C, which is consumption, and S, which is savings, all in the same graph, because essentially this happens as both axes have the same units.